If you ask me to list down top 10 things which have happened this year in the field of AI, I would mention BitNet at around number 6. The reason why I am so excited about this project because it opens up the doors for representing all of these huge models in 1 bit quantization. If you don't know what this bitnet.cpp is and what is meant by this really amazing paper from Microsoft 1-bit LLMs, I would highly recommend you to go to my channel and simply search with bitnet, and you should be able to find heaps of videos around tools, frameworks, architecture, concepts, and you should be able to get hang of this amazing technology. Just to give you a flavor of it, Microsoft's 1-bit LLM is simply amazing. By utilizing a 1-bit quantization, this drastically reduces the computational resources required for training and inference, which makes it more efficient and cost effective. The only problem with this BitNet is that it is a bit hard to install, and we saw that in various videos. Though if you're looking to install it vanilla, I would highly suggest you to watch the video which is on your screen. But if you want to just install it with few clicks easily with Docker, then look at this new project which I'm going to cover in this video. This project is called as FastAPI BitNet, and it uses Uvicorn, Docker and FastAPI all in Python. Uvicorn is the ASGI library, and by using this it gives you a wrapper, an abstraction to install BitNet, and then you can do inference with these 1-bit LLMs quite easily. 1-bit LLMs is quite interesting. The essence of this innovation is centered around encoding each parameter in the LLM using only 1.58 bits. In contrast to all of these conventional LLMs that frequently utilize 16-bit or 8-bit or even 4-bit quantization for parameters or weights, BitNet limits each parameter or weight to one of these three values: -1, 1 or 0. That's it. And that is how it reduces the memory footprint and all the resource consumption around LLM to bare minimum. So much so that you can even run 100 billion, 400 billion models on commodity hardware easily. Still very early days for this technology. So, but I am expecting a lot to be happening in this arena down the road. So I'm going to show you how you can get this FastAPI BitNet installed on your local system. We will also be downloading a 1-bit LLM from Hugging Face, and then we will do a small inference test on it. So let's get started. Before I do that, let me also give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. The VM which I'm using is this Ubuntu 22.04. My GPU card is NVIDIA RTX A6000 with 48 GB of VRAM courtesy Mast Compute. If you're also looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. I will also give you a coupon code of 50% discount on a range of GPUs. So let's get started. First, I'm going to create this virtual environment with Conda. I would highly recommend you go with Python 3.9 because this is compatible with all the packages which we are going to install. You can try out with 3.10 or 11, but 3.9 is recommended. So let's wait for this one to get created. Should not take too long. Now let's git clone the repo of this, and I will drop the link to it in video's description, and that is done. Okay, so next step we need to do is to install Hugging Face Hubs CLI because we need to download the model from Hugging Face, and that should be very quick. It's a very lightweight one, and you would also need a token, a read token from Hugging Face, which is a free token which you can obtain from huggingface.co from your profile after logging in. And you would need to log in like this with Hugging Face CLI. It is asking for my token. Let me put in my free read token. It won't be visible on the screen. And then just simply press capital Y and the login is successful, as you can see towards the end. Next, let's download the model by using Hugging Face CLI download command. And I'm just going to download this 1-bit LLM, which is 3 billion. It is going to download it. Let's wait. The size is not that big. There are only 3 shards. And the model is almost downloaded, as you can see. And that is all done. Okay, next step, make sure that you have a Docker installed. A recent or latest version would be good, like this. We need to download and then build the FastAPI underscore BitNet. Now this is where it needs to improve a lot, because right now it is running. It is going to take around 10 minutes to build everything from the source. Plus it takes around 35 gig of disk space. Yes, that's correct. You have heard it right. Everything including this. So make sure that you have that much space on your local hard disk, 35 gig. As I said, it is going to take 10 minutes or so. So I'm just going to pause it. Or meanwhile, I'll just give you a quick overview of our another sponsors. Very good friends at AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, public or private, any site, any URL, even behind authentication. It is quite resilient. Page structure changes, but AgentQL still returns the same result. It is reusable, the same query works across multiple similar pages, and it structures the output according to the shape of your query, and I will drop the link to their website in video's description. Okay, let's check our terminal. As I said, it is still running. There are 15 things to install. So we'll just wait and see what happens. So eventually it finished building it, and it took, as I said, around 11 to 12 minutes. Now let's run those containers, and that is now running. And we can access it on our local host at port 8080, which we already saw. So let me open it here. And now basically what is happening is it is serving this model with that bitnet.cpp by using FastAPI and running it on the Docker backend. And you can try it out. For example, if you want to check out the inference, click here, and then you can just give it any value. Like I can give it like this is a model at the moment. So you see, this is a model, this is a default value. You can just give anything. This is a required one. And then, sorry, let me go up. You can just check it out. You can say try it out, and then you can click on prompt. You can say hello or whatever your prompt is, and then execute. It is running at the moment. I will let it run so that you can see the response. It is loading the model. The first time it takes a bit of a time in order to get it loaded, and there you go. So this is the response. It's all HTTP. It's a Swagger sort of standard here, and this is a request URL, and you can see the 200 response. It has produced something, but I'm not worrying about the response. And so this is how you can simply use it as a server, serve the 1-bit models and use it. And as I mentioned earlier, if you want to learn more about BitNet models, how they perform on various benchmarks and prompts and testing, you can watch my these videos where I have covered it on in lot of videos. There you go. So a lot of them are there. And I started covering them around 8 months ago. Okay, so that's it. I hope that you enjoyed it. I will drop the link to this repo in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.